Today we've got a 2010 Ford F350, and the customer complaint is it's a intermittent no start. Sometimes it stalls out. This truck has been in here before, but what I found before was the inertia switch was opened up, and that can't be the case this time, because you can see the customer has gotten into the inertia switch and he's actually stripped the wires and twisted them together. So he also soldered them right at a really bad location. I don't know if I'm ever be able to repair that or not, but probably not the best thing to do. So first thing I do is print out the schematics for this circuit, and you can see right here, this is on our fuel pump relay. We should have one leg hot all the time, and that is fuse 32. It's a 20 amp fuse, and that's going to complete the circuit once this relay is energized, and it's going to provide power to the inertia switch right here. And as long as the inertia switch is closed, it's going to energize this leg and power up our fuel pump. So let's go over here to the fuse block, and what I've done, I've stuck my power probe. For those of you who don't have a power probe, I highly recommend getting a power probe and learning how to use it, because they're really invaluable in the automotive industry. But you can see the fuse block down below. Here's a better picture of it. And I am in the hot leg of the relay, and you can see we're at 7.6 volts. Now, I know we've got good system voltage with the batteries. That's been validated. So we're looking at a problem right down in this area. We're gonna trace back from there, check out the fuse block, and look at that fuse 32 position and see what we find there. Okay, just to validate that we're headed in the right direction, I have applied a jumper wire to our relay base power, which should be 12 volts all the time. I've just clipped it, I've just pinched it onto the positive terminal with my power probe clamp, and I've got the customer's meter sitting up on top of the dash, and that's measuring the voltage on the inertia switch. So when I turn the key, we should have 12 volts, and there you can see the needle rising, and we should be able to start this thing up. And there we go. So at this point, we know what the problem is. We're just going to work backwards, continue on, and find out what the permanent solution is for it. I have a feeling it's at the fuse location or the wire to the fuse block itself, powering it up, but we'll figure it out. One thing to note is you could actually solve this problem if you don't want to pay for a fuse block or get into any of that. You could put an inline fuse in this wire and just shunt that base right to the battery directly with an inline fuse. You should be good to go. So that would be a temporary fix if the customer doesn't want to pay a whole lot of money to have it fixed properly. Okay, so I went to fuse number 32, pulled the fuse out, and this is what I find. You can see the char marks on one side, which indicates to me that this fuse is not seated firmly. So there's a little tiny air gap there. You know, this thing is sitting in there arcing. At any rate, there's the problem. Problem is in the actual fuse holder itself. Okay, this is how we're going to attack this problem. I'm going to use this file here, and now you can get these files from Matco. This particular set came from Amazon, and I will post an affiliate link in the description of the video so that you can go to Amazon, and I think the price I paid was like $39. But for anyone doing a lot of harness troubleshooting, this kind of file comes in really handy. So I highly recommend, for those of you who are doing a lot of electrical diagnosis, to invest in a set of files like this. So next, what I'm going to do, if you can see, I'm just going to use my file. I'm going to go right straight down in the position 32. Well, my hand's in the way so you can't see. It's really tight, but the file serves two purposes. Okay, there's the file, you can see. Let's see if I can get my fat hand in there. Okay, right now the file serves two purposes. I'm using it kind of like a feeler gauge to judge how much spring is left in the contact in the fuse holder base. So one side is rather loose and the other side feels the way it should. It's got the spring in it. So I'm just twisting a little bit with this file as I insert it to kind of clean up the contact surface on the fuse holder base. And but we're going to have another issue, and I'm going to show you how to deal with this issue. So as I just mentioned, we've lost the spring that holds the fuse in place and provides a positive pressure against each of these blades, right? So there's a way to overcome that without replacing the actual fuse block itself, which is going to cost the customer quite a bit of money. So I'm going to run it by them, see what they want to do, but I've used this method in the past. I'm going to prepare the fuse the way I normally have in the past, and you're going to see how I overcome that spring. Okay, so here you go. You can see what I've done to this fuse, if it focuses. Let me try to focus it here for you. Alright, let me get it against the white background. What I've done is bent the tabs on the fuse itself, and that's going to take up for the lack of spring in the fuse holder base, right? This works 100% of the time. I haven't had it fail. As long as you've got 12 volts there, system voltage at that base, and it hasn't burnt the wires to the point where it's increased resistance and you're only getting like 8 volts or something like that, this method will work. The other option we have is to just remove that circuit entirely, put an inline fuse holder and an external relay in. That would work as well, but I think this is going to work in our case just fine. So there you have it. Okay, now I'm going to get my power probe, and we're going to go back in and check the base of that relay and validate that it's got constant 12 volts. Let me get my power probe in place here. Okay, you can see power probe is registering 12.3 volts on the base, so this is going to fix the problem without replacing the fuse block. Okay, hey, by the way, I'm going to post a link for the power probe. You can also get this on Amazon. This thing has been just, unbelievably helpful. If you're serious about automotive diagnostics, you're going to want to invest in one of these. Can't recommend it enough. Okay, next step, we're going to put the relay in, then we're going to fire the thing up and check it out, make sure it runs. Okay, back in the truck. Let's put the key in, see what we get. We should have meter movement when I turn the key on, because it's connected to the inertia switch. There we go. We got power on that. We're going to start her up now. Should fire right up. One thing I might suggest is check your fuse, right, with a pyrometer. And you can see I'm right on top of it. We're at 78 degrees. So if the fuse were sitting in the slot and it's not fully engaged, it'd be sitting in there arcing, which is going to bring your temperature up over 100. I always question a fuse that is anything over about 105 degrees. So if you're getting excessive temperatures on your fuses, then you've got another problem like high resistance in a wire, or you've got some laminations burnt off from a motor that's drawing excessive current. But so I'm going to post a link for those of you who do not have a pyrometer. So you'll be able to click on the link and get yourself a pyrometer. They come in really handy in automotive. So I think we've got a fix on this. We're going to give the customer the option to go ahead and repair it, you know, the right way. I'm also going to show the customer how I repaired it and let the customer make the decision on how they want the thing repaired. But this option is long lasting in my experience, and you shouldn't really have any issue as long as you haven't done permanent damage to the base where the fuse prongs go into the fuse block. If it's just lost a little springiness, just spring the fuse a little, jam it in there, and you're good to go. So, all right, just some tips and tricks. Thanks for watching. Now might be a great time to take a YouTube coffee break. Whether you love gaming, music, wildlife, or just need to relax a few moments, I've got you covered. Check out my playlist collection of epic Unreal Engine cinematic videos on your left, or my collection of nature music videos shot on location in North Texas on your right. Just be warned, once you start watching, it's hard to stop. Cheers.